Software Engineering Daily is sponsored by Hired.com. If you're looking for a job, Hired.com is the place to start. I've used it personally and it is an excellent service. Software engineers and designers can get 5 interviews in a week with top companies. Go to hired.com/softwareengineeringdaily for a $4,000 bonus upon accepting a job. Thank you, Hired.com. Steve Kinney is the co-director of academics at Turing School of Software and Design. Steve, welcome to Software Engineering Daily.
Thank you for having me, Jeff.
What is the Turing School of Software and Design?
So the Turing School of Software and Design is a 7-month developer training program. So given that length, we tend to shy away from the term boot camp a lot of times because it's a lot longer than any of the 9-12 week programs. But it's a 7-month program ultimately designed to take people who want to become developers. There's no real prerequisite for programming experience. Taking people who want to become developers and turning them into junior developers. Right, so we kind of we have some people have some background experience and have done this in the past. We have other students who prior to coming to Turing were baking, right? And
what is the requisite level of technical experience? I mean, if they come in with nothing, can they get in?
So there's no in the interview process, there's no coding challenge, right? There's no do you know what a method is on an object? There's no questions along those lines. We have them, they write an essay answering some questions about their personal experience. There is a logic test where we use questions from the LSAT, right? With the kind of analog being if you can the skills that you might need to solve these logic problems are skills that you might use in programming, right? But they don't involve programs. So we're looking for do you have the ability to learn how to program, right?
Okay, very
not that you have any
interesting.
skills.
So tell me more about that test. What are the things that a student has to be able to accomplish before they can make it in?
So there's first a written test full of logic problems where we look at both how many you got right as well as how long you took to get those questions right. And based on that, it's depending on how you do on the test, and you make a little video answering 3 questions and an essay based on a bunch of different factors. You either A, get invited to an interview, or B, you do not. And so in the interview process, it's a little bit more of, kind of talking to you, getting to know you, and then another set of logic problems. And the kind of, not to give away the secret sauce here, but the logic questions, yes, we care, can you work through these logic questions? But the major thing we're looking for is not whether or not you get them right, but how you go about approaching them and how you handle a complicated problem with a lot of moving parts. Right. And if somebody gives you feedback into a different approach to the logic problem, do you take that feedback and apply it? Do you kind of ignore it? Do you are you dismissive to the person trying to give you the feedback? Those kind of things. And we're looking for a lot of those kind of interpersonal skills because that's really important. We do a lot of pairing for students and in terms of if we kind of give you advice, can you take it and apply it are some of the things we're looking for when we do the in-person logic test. It's either in person or over Google Hangouts or Skype or something along those lines.
Very interesting. Yeah, I like the testing of the collaborative ability. So at Software Engineering Daily, we're doing a week of shows about these different types of computer science education, such as universities and online courses and coding boot camps. And Turing School falls in an interesting place along that gradient. So as you said, one of the differentiators of Turing School is that it's explicitly not a coding boot camp. So how would you define a coding boot camp, and how is Turing School different?
How would I define a coding boot camp? I think a coding boot camp is really useful for getting up a kind of building a foundation of skills that makes it very kind of possible to kind of go forward and get the skills to kind of go pro. right? And I mean, I know people. We have instructors who have graduated from some of the other boot camps, right, as well. And I think it's really great if you want to learn how to program and be able to apply it in your day-to-day life. We're trying to make sure that in the 7 months, like, we're not necessarily doing anything like outrageously different versus the 9 month one. We're just doing it longer and kind of going to a deeper level with it. So kind of like making sure that like the students that kind of graduate in that 7 month time are like well-rounded, solid junior developers who can kind of be ready to go on day one.
Right. So most coding boot camps are like 3 months long or so, but Turing School is 7 months. What can you do in that additional 4 months? What does it allow?
Yeah, it's really interesting because like we constantly struggle with the fact that we don't have enough time to fit in all the things that we want to teach. So it allows us actually. Like, I think the immediate thing that you might think, okay, the difference between a 7 month developer training program and a 3 month developer training program is 4 months, right? So like, and the difference must be in like month 4 onwards. And for us, that's really not the case. We kind of use that additional time. And we actually use a lot of it in kind of the early parts. So we break the 7 month program into 4 6-week modules. So you do a 6-week module. Then there's an intermission week where you have some assignments, but there's no like classes or projects during that time. And then you go into the second module, intermission, third module, intermission, fourth module, and you graduate, right? And having a longer program allows us to kind of go very deeply, especially early on. So one of the things that we like to say, like even on our website, is like we, for the most part, modules 1, 2, and 3, it is using a Ruby and Rails stack, right? But ideally, we want our graduates to obviously feel comfortable taking a Rails developer job, but also feel really comfortable taking any development job. So in the first 6-week module, with all this like time, what we're able to do is not teach Rails. Right? We teach object-oriented programming. We'll teach testing. We'll teach we'll teach them using the Ruby programming language. But what we'll try to do is teach all these different kind of concepts. We'll teach data structures and algorithms. Students will build linked lists and binary search trees. 2 of the projects right now that the Module 1 students are working on is one that takes text and translates it into Braille, and the other one that I believe takes a given kind of string of text and uses the say command in OS 10 to like say dum da dum da dum da like a drum machine, right? So we can get really into like general programming concepts without having to like rush them into Rails development and the kind of inner workings of a given framework, but to try to like really strengthen that foundation that if they wanted to go take a job teaching or rather programming with Python, like our goal is that they feel well equipped with the foundations of programming to go ahead and do that.
Sure. Okay. So I think this brings up an interesting point because coding boot camps tend to emphasize the practice side of theory versus practice. And I don't know how you see this dichotomy, but does Turing School focus more on theory or practice?
I mean, the goal is probably a healthy mix of the two, right? All the theory in the world with no practice isn't very useful, and memorizing a bunch of techniques and Rails without understanding what they're doing is not helpful. So what we try to do, obviously, is, and that's, our best attempt is to balance the two. Right? We want you to know how to do things and how to create web applications, have something to show for yourself at the end of the program, right? A portfolio of projects to show employers. But our goal is that if one of those potential employers does a code review with you, that you can speak to why you took that approach. Right? Like what you were thinking when you decided to go about it that way, or what's happening under the hood in a given case.
Yeah. How do you define this difference between theory and practice?
I think it's a lot of the like how and the why, right? Like how do you get like something into the database, or like why does an object relational mapper work the way that it does, right? How does HTTP work rather than just sending requests, right? And like why are things structured this way? Like I personally teach Module 4, which is actually focused a lot on JavaScript and client-side development. And rather than saying, okay, well, asynchronous JavaScript works like this, and you just have to like either store this in a variable and pass it along or something along those, right? Like understanding how that mechanic actually works and like why you have to do that, right? So that you like, it's not just like I have memorized these moves, but I have some kind of like understanding about them. So a lot of times we always try to make sure students have multiple things to do. So
Sure.
a given day, probably, and it depends on the instructor. I'm a morning person, so guess when lectures are? They're in the morning. But like a morning today, we talked about test-driven JavaScript, right? And how you might like mock out Ajax in the browser so that you can test different things without needing a server running, right? So we'll kind of like talk about like the theory and like the how it happens, like going about it. But at the same time, this afternoon, all of our students are working on a project right now. Right, so they're actually going ahead and implementing something that's not just like isolated to that lesson, but the lessons then support this independent project that they're working on. And this afternoon I spent a lot of time doing check-ins, doing code review with them, like in the context of their project. So there's always like multiple things that they're working on at a given time, but hopefully, in a perfect world, all reinforce each other.
Okay, and how do you think Turing School compares to an academic computer science education?
So I think a lot of it is, it's one of those things. My brother-in-law is actually a student at this point, and so when he wanted to apply, like I got asked a lot of these questions very directly, like how can somebody go through one of these programs in 7 months and get a job that pays a pretty good salary these days? I think part of like the major thing is how accessible a program like this is. Right, we have students who are parents, right? We like a lot of people can find 7 months of their life, right? And even that's a really like accessibility, even for a program of our length, it's really hard. Most students will pay more in cost of living; they'll pay more in rent than they will in tuition to us, right? So part of what we have to do is try to make it as accessible as possible. But it's a lot easier for people to do a intensive 7-month program, and hopefully the salary increase that they see at the end like balances out with the kind of like risk that they took going in. So I think some of these shorter length programs are able to attract students where going through another 4-year degree, not only for the time commitment but also the expense, would be unattainable.
How does the content compare?
I don't have a computer science major, so I can't speak too much to this, right? Like, so like full disclaimer, I have a liberal arts degree. I think. So our executive director, Jeff Casimir, has a computer engineering degree, and he'll usually say that like a lot of the stuff that he learned, he didn't actually apply as a software developer.
Yeah, I can vouch for that.
Yeah. Okay. All right. So I got somebody who knows what they're talking about here. That's great, because I don't. But I think that we are there. There is this kind of focus on we were talking before about the balance of theory and practice, right? Well, we were talking like. One of the things that we're able to do in 7 months is get a lot more of that theory and then some other programs. The other thing that I think compared to a 4-year program for us is like we give each and every one of our students a guarantee saying that if you can't get a job in 3 months, here's your tuition back. Right? So the impetus is also on us to make sure that like you have the practical and necessary skills to be a junior developer at the end of that 7 months. Right? So there is that there's a little bit of an accountability on our end that we have to give you also the practice and practical skills to be able to be a like person in this industry.
Yeah. Interesting. I mean, so one of the other benefits that people talk about with academic education is this socialization aspect that you get from a big university. How valuable is that socialization? And like, can you get it outside of a university environment? Like, does Turing School effectively mimic the socialization that you get out of a big university?
I don't know if it mimics it. I know I can speak to the fact that it's a priority for us. Right? Whether or not it mimics it completely, that's never really been a goal for us, right? If it does, and that's a good thing, great. We focus a lot on community. So we just hired a student experience manager whose job it is to kind of like focus on that aspect, but it's always, even before that, been definitely something like really core to our mission. So normally there's traditional teaching and projects and everything along those lines, Monday, Tuesday, Wednesday, Thursday. On Friday, we don't do that. On Friday, it's kind of a day kind of more focused on community. So we have students who are giving lightning talks. We have students who are running sessions themselves, teaching something that they're super interested in. And it might not even be something that's in the curriculum, but like a student that has maybe some experience in DevOps might teach something on DevOps. A student who's kind of really interested in doing generative art and processing might teach a session on that. We also try to bring in guest speakers from the community to kind of come in and like do Q&A sessions, either remotely via Skype or Google Hangouts, or to come in person. And we've been trying to like add additional like events around the different school days and on weekends to kind of like build that community aspect. So whether or not it mimics it, I don't know, but
Right.
it has definitely been a focus that like the community is something really, really important to us.
Well, how do you see your students interacting with each other? Like, I talked to Will Sentence, who is a guy who works at a coding boot camp called Codesmith, and
Cool.
he was saying that the social environment is so strong at the boot camp that the relationships that form really persist afterwards. There's like a really strong formation of bonds.
Yeah, I remember when I was taking a social psychology class as an undergraduate, there was, and I might get some of the details wrong, but the general idea is, I think, accurate. Basically, there was an experiment where there was some kind of like social club, and half the control group was able to just join the group, and the experimental group had to go through like this like hazing ritual where they had to like read some like thing and do like some public speaking thing in order to get into the group. And the end result of the experiment is that those who had to go through like the arduous task found more enjoyment and claimed to have tighter social bonds with everyone in the group after the fact. And I think about like the fact that like, yeah, I mean, a bunch of these people have given 7 months of their life, and like we work them pretty hard, right? Like the day starts at 8:30. Like we do wrap up at 4, but like I've been in here at 9 o'clock on a Saturday, and there's probably like a quarter of the student body here then, right? Nobody actually leaves at 4. So for a lot of people, like this is a really intensive thing. For some people who are like trying to do a career or life change, like this is probably their like one or maybe last shot at like doing this. For some people who like, if they're in a relationship, their spouse might be paying the bills. Like this is like they're putting, their whole family is making a sacrifice. So I think doing something so intense and so like, I think difficult does actually create a lot of those bonds versus kind of like if you showed up once a week for a Wednesday night class for 2 hours, you would probably not have those same bonds than being up at 3 a.m. Stressing out over a project or like pairing with somebody. I think you end up with stronger bonds.
So this is so interesting. We're getting into a discussion of the content and the experience of the class. Give me an idea of the 7-month arc that students go through at Turing School. What is the beginning, and what are some milestones along the way?
Yeah, that's a really great question. So there's the module 1 is definitely, you've got this, module 1's really difficult for us to teach because there's this wide range of experience. Like we have no requisite that anyone has any experience. At the same time, we don't like turn away people that have like some amount of programming experience. Like I was self-taught. And like significantly like later in life, but I was self-taught, and I wish there were programs like this. Kind of when I was interested in software development, I would have done it, but I definitely would have been somebody who like I had played around with programming. I knew a little bit of Ruby and JavaScript. Like I could make a web app. It wasn't good, but I could make one. But I didn't necessarily have like the professional skills to get a developer job early on when I was teaching myself. So you have this like wide range, and that causes a lot of like interesting dynamics where there are people who don't have any experience who kind of get into this room with people who do have some experience, and it becomes really kind of interesting to like battle imposter syndrome, like where you go, I can't do this because everyone else can. Well, we've noticed that like by module 2 there's kind of this great evening out where there's no kind of correlation for us between the people who come in with prior experience and the people who are our strongest students in module 3 and 4.
Wow.
Right, like it gives you a nice little head start, and in some cases, the people who started with the head start kind of like are used to relaxing, while the people who started out without any experience are kind of used to like struggling, and kind of like have been like trying, so that eventually they kind of pass that. But there's also like eventually like we kind of get everyone up to the same place, and that usually happens in around module 2 or 3. And some of our stronger students are students that didn't have any programming experience but had a lot of like project management experience, right? So they know how to like avoid rabbit holes and how to kind of like prioritize different features in their application and end up with like higher quality products than students who might be technically stronger. So in module 2 is kind of this like there's usually like this kind of like cohort wide like sense of peace among students in module 2, where they've kind of like gone through the kind of like life change of module 1, and they're starting to like hit a rhythm, right? And they're usually like pretty happy at this point, and they love everything. The one thing,
and so I'm going to interrupt you.
Mm-hmm.
We'll continue going through the modules, but I want to get an idea of like what are the languages and frameworks that these students are learning early on in the process.
So module 1 is simply the Ruby programming language, right? Okay. And ideally, it's programming languages at large just using Ruby as the first language. In module 2, they learn Sinatra and just HTTP, and they basically learn the web. In module 3, it is kind of, we call it like professional Rails applications, where they're building multi-tenant Rails applications, and they're worrying about security, and they've got to get response times under 300 milliseconds or 400 milliseconds, and they are kind of like starting to dabble with some more advanced JavaScript features, and they do their self-directed project where they kind of like come up with an idea and like kind of see it through. And then module 4 is a big focus on scaling Rails applications. It's like, okay, you made a Rails application, that's great. What happens if it has like 400,000 rows in the database and is getting hit with 1,000 requests every 10 seconds, right? Does it stay up? But the biggest focus is JavaScript. JavaScript, a little bit of Node, a lot of like client side, mostly again language fundamentals, and then also kind of rounding back to language concepts like JavaScript, but then using JavaScript as the kind of mechanism for teaching some more advanced programming concepts that are available in other languages. Like we'll talk about like closures and like functional programming concepts. And JavaScript, like Ruby was the vehicle in module 1, JavaScript is the vehicle in module 4 for teaching those skills and ideas that our students can hopefully like apply to other situations and a lot of times bring back to their Ruby as well.
Yeah, okay, so the different boot camps that we've talked to, they either teach Rails or they teach a full stack JavaScript. It sounds like you teach something that's somewhat in between, like you start off focusing on Rails and then the focus shifts somewhat to JavaScript at some point. So maybe you could talk more about that. What's the impetus behind that structure?
I mean, the impetus behind that structure is, the previous incarnations of Turing, which were G School, which still exists today, and Hungry Academy, were, I think, full the way through like Rails jobs. Rails like focused curriculums to get our students develop, jobs as Ruby developers. A big kind of focus is that we have noticed that even the beginning of Turing, I would say we were closer to just the like full Ruby on Rails curriculum. We did notice that we had a lot of students that were still taking jobs as like JavaScript developers. Right, even the fact that like early on we weren't teaching a ton of it. They were taking, there was this whole like wide like job market, and that's a lot of students like started with Ruby but found themselves like kind of passionately interested in JavaScript and interested in solving like front-end problems. So some of it came just like at student requests. I started my kind of like career as a Ruby developer who kind of found myself in the same position, which is that like I actually found that I enjoyed writing JavaScript a lot more. So I would say in around January, we kind of shifted the way we did staffing, and instead of everyone teaching everything, there's like an instructor who kind of sets the curriculum for each module. And so it kind of became this kind of feedback loop where students were getting more interested in front-end development and JavaScript, and thereby I was like, well, I'm into this. Let's go deeper and do more. And then the next group would get even more interested, and we'd go deeper and do more. So it wasn't necessarily a like set decision, but rather this kind of like natural thing. And it's really interesting. On the other hand, in the early days, we started teaching like JavaScript frameworks right after Rails, right? Without really a big JavaScript foundation, we were teaching Ember. And in the same period of time, we kind of like dialed it back from teaching Ember to like more about JavaScript fundamentals.
Interesting. And so, like, what are the fundamentals of JavaScript that you feel you need to teach? Like, what are the things in JavaScript that are important, agnostic of what framework you are using? Yeah,
so JavaScript's got its, let's just call them interesting characteristics, right? So there is there's a lot of like kind of funky things to learn about language, and a lot of like interesting like ideas, right? And one of the things that I kind of hate about many JavaScript books and stuff along those lines is they usually become like a vehicle for the author to kind of demonstrate all the weird quirks of the language that they've kind of memorized. And we had a whole bunch of students who would like read these books and be like, I can't program JavaScript because I don't really understand how like true plus true equals 2. Right? I'm like, listen, that has never come up for me. Like, it's actually probably bitten me once, but like other than that, like, so there was this kind of like, it also started as like this reaction to like, no, like there is a core set of things that you kind of need to understand. And so for us, some of those are asynchronous JavaScript. Like, how does async work? And it's one of those things where it's not necessarily like complicated, but for many of our students it's confusing, especially because like some of the more like Ruby kind of like just ignores the whole issue, right? It'll block as it goes to like access the database and then give you the result. So kind of I think asynchronous JavaScript is definitely like a language like feature that like we've definitely felt like is important to understand anything you do on the client side, whether it be in jQuery or whether it be in a more advanced thing like React or Ember. The other one that I think is really important is understanding this in JavaScript, which is kind of like that the idea that because functions are first-class citizens in the language and you can pass them around, where you wrote the function and what this was when you wrote the function is not necessarily the context in which that function is executed. Mm-hmm. Right. So kind of like explaining and demonstrating and kind of like building examples around those ideas and kind of like showing like I think 2 days ago we wrote the ES5 function prototype method bind from scratch, right? And yeah, it wasn't like as great as the one built, like the actual like one built into the language pieces, I think does a whole bunch of like edge cases. But we built a working version which kind of helped explain how this changes and wrapping functions and other functions and like using call and apply to kind of like make this happen. I think is really important for doing any like ambitious application in JavaScript.
Cool. So I think you've mentioned about I don't know what percentage of the modules you've mentioned, but maybe you could explain the remainder. You kind of have explained the student ramp up through Ruby and then Sinatra and then Rails, and then you move on to JavaScript and JavaScript frameworks and concepts taught through JavaScript. What comes after that? How does the class conclude?
I mean, that's at that point. That pretty much brings us to the end of the 7 months.
Oh, okay. And then what happens at the end of it? How is the how do the students transition to looking for jobs?
Yeah. So in between module 3 and 4, we have the jobs talk with them, where Marissa, who kind of does like the jobs kind of. She helps students, kind of work through that process, kind of talks about resumes. And then every Tuesday, we do like technical interview prep, where it's basically like, data structure and algorithm challenges that you might find in a technical interview, and like have students like kind of work through those problems and collaborate and code review each other's problems. But they start the job hunt at the end of module 3, transitioning into module 4. So in that intermission week beforehand and like throughout module 4, they are They're going to technical interviews. They are having phone screens. I've got 2 students who are getting on airplanes this week, being flown out someplace to kind of do an in-person interview. So it starts to happen through Module 4, right? And so some of them, a subset of them, will have jobs by the time that they graduate, right? And the subset will kind of be still going through the interview process in some of the weeks directly afterwards.
Okay, and let's talk more about the economics. Like one thing I'm curious about is like, I've had this discussion a couple times over the past couple weeks. Is like, is there an upper bound on how many developers can contribute to the economy? Is there an upper bound to how many developers the economy can support?
Yeah.
What's your perspective on that?
So this is a fear near and dear to our hearts. So on one level, like, we are a nonprofit, right? We don't have any like venture capital like bucket of money that we can like tap into if this like turns south. Like we have to be really aware of those things because we are completely bootstrapped. At the same time, we're making tuition guarantees. So we're hoping that like, we're kind of like saying we're going to invest, all of this. And if you don't get a job, like, we're not going to like reap any of the financial rewards from it. At the same time, we have these 4 modules, but we have students in each of the 4 at any given moment. So we start a new class every 7 weeks. So we have students in module 1, 2, 3, and 4 right now. And so that means every 7 weeks we're graduating like 20 developers. So it's one of those things where it's early on it was worrying about competing with other developer training programs for like a given set of jobs. I think some of the fear now is like we'll reach out to some of our companies that we're friendly with, saying, hey, are you interested in hiring any developers? And they went, well, no, not right now, because we literally just hired 3 of your graduates like 3 weeks ago, and we can't take on any more juniors. So for us, sometimes like we are our own worst enemy in that case of like, and especially Denver is growing very quickly. And like, it is definitely like a really great scene right now if you're interested in technology, and it's growing very quickly, but sometimes like the fear is like worrying about like outpacing the like demand.
Right. So this is the bottleneck that I've heard, where you have a team that has like 2 or 3 senior developers, and then like you get to 5 or 6 junior developers, and it's like, we don't have enough bandwidth to onboard somebody new. It's not that a company has a limited set of tasks they need accomplished. It's that they need senior developers to accomplish those tasks, or to help junior developers learn to do those tasks.
Yeah. I think that's a really real thing. And I think that is incredibly true at the individual company level. I think one thing that we found is that I don't think we've hit the like peak of number of companies though, right? So it's like almost like a concurrency thing. You can overload a given company with like, as they try to keep that balance between onboarding juniors with their senior developers. But I don't think we've hit the peak for the like number of companies out there. There's definitely like, we have some companies that we have, I think of one company right now that kind of was like, yeah, like they were friendly with us, and they were like, yeah, we're not really interested in hiring somebody from one of these programs. Yeah, we're not super interested in it. And they hired 1 student out of our first class. And since then, like that broke down the dam. Since then, I believe there's like 5 or 6 students that they've hired in like the last 6 months from our program. So some of that is like opening up more of those doors. I think that there's still a lot of people who would say, well, I would never hire somebody without a 4-year degree.
Right. Okay. So some of it is actually stigma. Some of it is not this we don't have enough room for junior developers. It's just stigma against coding school people.
Yeah, and a given company only has enough room for a certain number of junior developers, right? Like, that company probably isn't in a position to hire one of the students from our current class because they just took on, I think, 2 or 3 from our last class, right? That is still true for that individual company, but I think that there are a lot of companies, and in Denver is like growing so fast that like there'll be like a company like down the street that we didn't even know existed yet. So there is like kind of the known companies that aren't really interested that we have to kind of work on, because once a company hires their first Turing graduate, at that point it's like smooth sailing. Then they want to keep hiring them. So there are the companies that don't know that they how desperately they want our students, and there are the companies that we don't necessarily know exist yet.
So the former half, the people that don't know, the companies that aren't really looking to hire Turing School graduates, do companies like Google and Facebook and like just giant companies, do those fall in that bucket, or have those companies converted to liking like coding school graduates?
I don't know that we have ever, even in the previous iteration, so Hunger Academy and G School, I don't know if we've ever had a student that has gone directly into Google or Facebook or any place like that. I think that those are really, a lot of our students, they're good junior developers, but they are still definitely learning. And I think a lot of those, my hope is that they become really great second or third jobs. Right. The other thing that we've seen, just kind of round back to your previous question, that between our previous programs, one thing that's been kind of really great to see is that many of the graduates from Hunger Academy, which was in 2012, right, are now in the position to hire. Right. So if you think about like some of those companies that maybe said, I would never hire someone from this program. Now some of our earliest students have, maybe they didn't start out working there, but like they got hired as a senior developer. They don't have that mindset because they graduated from one of these programs and they're like, send me your Turing grads. I'll interview them all.
See, this is interesting. So how long does it take, a student graduates from Turing School, goes to work at job number 1. How long does it take for that person to become what is classified as a senior developer?
Yeah, so I'm really interested in this question because I've actually been thinking a lot about it. So Turing's only been around for a year, so we don't totally know with Turing graduates. But Hunger Academy was an interesting one because that was done in conjunction with Living Social, right? So the idea was that Living Social was going to hire, I think, like 20. They were going to bring on 24 people who showed promise at being great developers, and they were going to hire some subset of them. And they ended up hiring all of them. Right. And some of those students do have job titles that say senior developer these days. Right. Some of them are in the position where they are making hiring decisions. And so that was 3.5 years ago. So that's an anecdote. That's not like a large, like I have the data to like say 3 years makes a senior developer. That always struck me as like very quick.
I would totally believe that.
Yeah.
I would buy 3.5 years. I think a lot of it is, just my personal experience. I've worked at several jobs, and I think a lot of it is driven by how hard you're willing to work. If you work for 3 years, like if you come out of a coding boot camp, you get pretty good knowledge, you work your butt off for 3 years, you're a senior developer.
Yeah.
Like there's no question. I think so much of it is A, being in the environment, and B, it's like a meta. It's stuff that changes all the time. So it's basically like there is a certain type of material that is popular, that is important to learn. It's like JavaScript. Is JavaScript going to be super important in 10 years? I don't know, maybe not. It wasn't super important 10 years ago. It wasn't super important 5 years ago. So people that have been in the industry a really long time, they don't necessarily have a leg up on anybody else. That like when technology refreshes, that's like a new opportunity for quote unquote junior developers to ramp up to senior developers at an even pace with people who have been in the industry for a long time.
It's kind of like the joke of the Swift developer with 5 years experience.
Right. That's exactly right.
Like we all use like mobile phones, and none of those platforms existed like 8 years ago. So you could be definitely a senior developer in that sense. It's definitely really interesting to think about, the kind of like how hard you work thing too. One of the really common things from all of our students is they get out of Turing and they get out into like the, let's call it the real world. And their first reaction is like, this is a lot more slower pace. This is easier than right, because we like, it's for us like
train them right.
Yeah, we're trying to cram so much into 7 months, and they're a lot of them, our most motivated students, are trying to get so much out of their time here that like when they transition into their into things, they're shipping like one user story, like a day or something like that. They're like, oh my, like, so if they can kind of like have the self-discipline to keep themselves like motivated and they keep that work ethic that they had while they're in Turing or any of these programs, I think that's probably one thing that they all share in common. It's not necessarily the length, but I would say the intensity of all of them is probably on the higher end of all these programs, right? If they can keep that and keep that kind of like, I also think that there's probably less like ego, like, you're very comfortable not knowing things because you didn't know anything 7 months ago, 3 months ago, 12 weeks ago, right? You didn't know anything. So like you don't like, you're very, I think a lot of times willing to like take on something new because like, well, you didn't know Ruby 7 months ago and you seem to know that.
We'd like to take a moment to thank our sponsor. DigitalOcean offers simple cloud infrastructure for developers. In one click, you can have a mean stack, a Rails application, an Ubuntu box, or another custom environment. Software Engineering Daily is proud to have DigitalOcean as a sponsor because DigitalOcean is the simplest cloud service provider. I've interviewed Moisey Aretsky, who is a founder of DigitalOcean, and he told me that DigitalOcean was based on this realization that other cloud service providers are so complicated. If you want things to be simple when you deploy your application, use DigitalOcean. To try DigitalOcean, go to digitalocean.com and enter promo code SEDaily. That promo code is one word, SEDaily. Now let's get back to our show. Well, and here's something that's great about that, because I think that, I don't know about Turing School. It sounds like this is the case, but other coding boot camps I've talked to, they really take this idea of imposter syndrome like head on, and they address it and talk to people about it. And they're like, you will feel like an idiot, and they tell people that at the beginning, and they recognize that. Speaking as somebody who went through a 4-year degree, nobody ever really tells you like you're going to feel like an idiot during most of this. It's much more the opposite. It's much more the ivory tower. I had a professor tell me recently, this is a professor from my school that I went to, my university, UT, and he said, there are just certain people that shouldn't be in computer science. Like, they're not good enough. They're not smart enough. And I was like, you are a person that has been allowed to teach university. Like, that is not the approach you should take. No, and that just shows the polar difference between how computer science is taught in this ivory tower versus somewhere where, like Turing School, where they say it's okay to feel dumb for a while.
Yeah, it's definitely okay to feel dumb. I think.
And as you said, like, that's actually important on the job to feel on the job. Like, I'm dumb at the beginning. It's okay.
There's a really great Carol Dweck has done a lot of really great studies about and I don't remember the exact terms, but I think it's like a fixed mindset and a growth mindset. And the fixed mindset is like you believe you are smart or like whatever, and you have a fixed like intelligence in you. And the growth mindset kind of treats it more like a muscle, right? Maybe you're like, I probably couldn't lift a lot of weight right now, but like I know that like if that was something that became really super important to me, like I could go to the gym and like build those muscles. And the really interesting thing that they found was, I think, and again, I'm like doing this study from memory, right? But like they kind of gave a bunch of 5th graders a math test that was too hard, right? And basically the students that had like the kind of fixed mindset thought to themselves like, well, this is too hard, I can't do it, therefore I'm obviously stupid And like if they took it, like if they couldn't do it, well then that was just like, you know, where they fell on that measurement scale of not good enough. And the students that took it as like had the growth mindset that your intelligence or whatever is a muscle that you can train, took it as a challenge and ultimately performed way better on the test. Right, regardless of anything else, like took it as like an opportunity to grow. And I think for us, a lot of times is building is how it's not, you know, like you will feel stupid, yes, but like the idea is right how you then approach that, like, and you will have the opportunity to like get really good at this by first caring and secondly like just sweat equity in it, you know.
Yeah, so, okay, let's talk more about this notion of, like, how do you teach? How do you do education? You've been in the education business for a long time. Or education business is a weird way of putting it, but you have been teaching for a long time in one form or fashion. And you've also been in New York for much of your career. Now you're in Denver, which is where Turing School is. So New York recently announced this intention to teach computer science in all high schools within the decade.
Yeah.
Is this feasible, and like how do you implement that?
I have those exact same questions. So like I taught Ruby and JavaScript in a middle school classroom, right? I started out as like a special ed teacher, and then like as I got better, like I just kind of ended myself up in that kind of position. I'm curious on like where they're gonna find all of these computer science teachers, and some of that like. New York actually like doesn't pay great, but it doesn't pay as like hideously as some other school districts. But it certainly doesn't pay as well as like a software engineering job in New York. And what's more important is the work environment is probably not something that most people with software engineers are kind of used to. It's not necessarily the most the friendly. Like if you're used to like going over to the kitchen or wherever you work and making yourself like a coffee and coming back, like that's not going to happen. Like for me, there is nothing more humbling and a little bit depressing than the average quality of the teacher bathroom in a public school.
Oh.
Like, generally speaking, it's gross, right? I think in my wife's school, it was like, there was one bathroom for the entire staff, right? So it was a single person bathroom then, because like, you can't have, you know, genders, right? But like it didn't have one stall had a working toilet and the other one had a door.
Yeah, that sounds awful.
Yeah.
I mean, but from an institutional perspective, like how would you teach? So let's assume you have enough teachers, I guess.
We have the personnel first and foremost. Okay.
Yeah.
Yeah. I think the kind of important thing is, you know, my fear with those is that they're going to become typing classes, right? I think the kind of trick is to embed it into the curriculum. Right. And there are some schools that do this already. Right. There is the Academy for Software Engineering in Manhattan, where it's not that you take math and then you go to computer science, but it's rather that your freshman year math class is taught, you know, using Racket, like the functional programming language, as like a mechanism for teaching these things. Right. I think it would be really interesting in like a history class to like take some like historical data and like, you know, map it out or something like that using like an algorithm or something along those lines. I think that there's a lot of opportunities to embed it in the curriculum. But that almost again doubles down on your staffing problem. It does involve that like you have, you know, a math teacher like that's also like capable as a developer, or a developer who, you know, has the background in math as well. So there's some of that going on. But I think embedding it into the curriculum is, I think, one really great way to do that. I mean, two is like the bar is so low at this point that literally doing anything would be a really great improvement. There's also a program that I really like, and I think that they're still doing this, 9 Dots in Los Angeles, where they have like they run like a community center kind of focused on like STEM skills, but they're basically running a program with 2 schools in Hollywood where they're kind of going in and from first grade up, trying to integrate computer science into the curriculum, right? So first teaching the teachers the concepts, and then helping them build curriculum that includes those concepts. So like that involving like Scratch and some of those other things in the early years, and then kind of moving up to like JavaScript kind of as the kind of like default lingua franca language these days, in like 5th and 6th grade, and like just kind of like doing it piece by piece over the time, but also like building capacity in the teachers across the curriculum. Not so that there's one teacher that knows how to do this, right? But that like every teacher has a certain kind of level of competency in that as well.
So I want to begin to close off by talking a little bit more about Turing School. On the Turing School website, there's a section that reads, Turing is on a social justice mission to open the world of computer programming to more great people. Mm-hmm. What is the social injustice that Turing School is trying to fix?
That's an interesting way of phrasing it. I didn't actually think of it in that sense. I think that I don't think that everyone has the same access to one, just like technology writ large, and then two, kind of the skills, access to obtaining the skills to work in this industry, right? And I think we've seen that by the fact that, like, if you go to any developer conference, like, you don't have the attendees are not a representative sampling of the American, like, population, right? You don't have the same amount of women as you don't have 51% women at a given tech conference. You don't have the same amount of people of color in like a tech conference. You don't have any of those, right? Which says that in the default state, right, there's definitely something is not working, right? Where there's not enough people who have access to getting, to these things to be able to kind of like be in this community. And part of what we're trying to do is try to eliminate that as much as possible, that everyone kind of has access to this this career if they're interested in it, right? Like, it's obviously not forcing everyone to become software engineers, but for anyone interested in it, that we can provide them with the resources that they need. So, like, part of that... bigger question, will they have a choice? Will there be a choice, or will you have to know how to engineer software in the future? I do think that it's at the point where, like, and I was thinking about that in terms of, like, when we were talking about, like, integrating it into the curriculum in schools, right? Like... Yeah, it should be in every subject, because in one way or another, like, if you're going to even be like a scientist these days, you probably need to know some Python, right? And that every like field is going to need a certain amount of this. I think at the same time, like, while the bar for how much technology like everyone needs to be comfortable with raises, so will the like bar for being a software engineer, right? Like, 10 years ago, it wasn't like you didn't necessarily, maybe 20 years ago, you didn't necessarily need to know how to use the internet. These days, everyone needs to know how to use the internet, and at the same time, the level of web applications that we develop has also kind of like risen in the sophistication as well, right? Yeah,
so how old are you? Are you a millennial?
I am a millennial. Okay,
same here. So when you look around at your friends and people who are around your age, people that you went to high school with, and you look at their current jobs and you extrapolate their employability towards the future, do you see any worrying trends?
I mean, I see worrying trends in my own like life. Like, I became a teacher, and I was really happy in that career. My parents are teachers, and I had always been teaching. But at the same time, with a liberal arts degree, there weren't any other jobs, right? I had a sociology major. There's no job called sociologist out there, right? So I think it's already kind of the case in a lot of senses. Like, yeah, I think for a lot of jobs there is this. I think everyone is going to need to know, like, a certain amount of how to program, right? And I think at a certain point, like, there's just efficiency gains, right? I kind of learned, I had always been interested in computers. I worked in the computer labs in college, and like, I knew like how to do HTML and CSS from a very young age, and I bought a book on JavaScript at 14. I didn't read it, but I bought a book on it, right? So I was at least in that mindset. And for me, learning how to program was when I was a teacher, it was kind of, I started teaching in 2006, which was really in like full swing of the whole like No Child Left Behind thing, where the big thing was collecting data on your students, right? And so the way that you collected data was you basically would, do like a reading inventory with them or some kind of skill assessment with them, and you would like write notes on like Post-it notes and like put it in a binder. Ugh. And you'd record a bunch of data, but how were you ever going to like process that data, right? And at the time in New York City, I think like the city had paid like IBM or something like $50 million to build this like database of like that was supposed to aggregate all the student information, and it was
Post-it note aggregator.
Well, yeah. Well, you had your Post-it notes, and then you would basically bring them to this thing that basically was like all of their like standardized test scores and like any of those things. And it was a $50 million Drupal app, and all it allowed you to do was download a whole bunch of separate spreadsheets for any given set of tests. So we had like 5 or 6 teachers who would get paid overtime, and they would basically cut and paste columns based on like you'd have like the student ID and the student name, and you'd basically cut and paste the columns from all the different spreadsheets so that you could share it with all your colleagues. And I didn't know how to program yet, but I was like, this seems like something that I don't really know what a relational database is, but this seems like something that a relational database would be really good at, right? And so I learned how to program because like I could not bear to cut and paste another spreadsheet column, and there was an efficiency issue here. Like there was 5 people doing this, so I basically like kind of like taught myself Ruby and like Rails and like built a thing that kind of like replaced all of that, right? And like even that was like a few years ago, and it was like even then like that was something that I needed in order to be really effective at my job. The difference was the need was there, but it was so commonplace that nobody had the skills that like there was no expectation that you had the skills. Like basically the organization was so used to like running at a certain amount of inefficiency that it was just taken as the new normal. But I think that the need to do all these things is already present. The ability to do it is already present. And like I didn't need to know a ton to like be at the point where I could be useful at solving that problem, right?
Yeah, that makes a lot of sense. Well, all right, Steve, Kinney, it's been awesome talking to you. This has been a super interesting conversation about Turing School and all the other interesting topics we discussed. Thanks for coming on Software Engineering Daily.
Thank you so much for having me.
Yeah, it was a real pleasure.